First gear. To shift into first, depress the clutch pedal to disengage the clutch. Move the gear shift lever to the first position. This causes linkage in the transmission to select the first position. This causes linkage in the transmission to select the first reverse synchronizer, and it moves to its sleeve locks to the first speed gear. Since the synchronizer and sleeve assembly are locked to the output shaft, the first gear drives the output shaft. The first gear drives the output shaft when the clutch is engaged. In first gear, there is torque multiplication and speed reduction through the transmission. The main drive gear is smaller than the counter gear it drives. This provides gear reduction. There is more gear reduction as the small counter gear drives the large first speed gear. The gear reduction can vary. A typical first gear ratio is about 4:1. The crankshaft turns 4 times to turn the output shaft once. There is further gear reduction through the final drive in the rear drive axle. Second gear. To shift into second, move the first second synchronizer sleeve to the left. The sleeve moves through its center or neutral position, unlocking the first speed gear and locking the second speed gear to the output shaft. The second speed gear, driven by the counter gear second gear, now drives the output shaft through the synchronizer sleeve. There is less gear reduction than in first gear because there is less difference in size of the gears. A typical gear ratio for the second gear is about 2.4:1. The input shaft turns 2.4 times to turn the output shaft once. Third gear. In third, the first second synchronizer sleeve move to its neutral position. The third fourth synchronizer sleeve moves to the right so that it meshes with the third speed gear. The counter gear third gear now drives the third speed gear and the output shaft through the synchronizer. A typical gear reduction in third is about 1.5:1. Fourth gear or direct drive. In fourth, the third fourth synchronizer sleeve moves to the left so that it meshes with the main drive gear on the end of the input shaft. The output shaft is now driven by the main drive gear through the synchronizer. This is direct drive and the gear ratio is 1:1. Fifth gear or overdrive. In fifth, both first second synchronizer and third fourth synchronizer move to neutral. The sleeve on the fifth synchronizer moves forward. This locks the fifth speed gear to the counter gear. The fifth speed gear now turns fifth gear, which is splined to the output shaft. Overdrive is provided because the fifth speed gear is larger than the gear it drives. A typical overdrive gear ratio is 0.8:1. The output shaft turns one complete revolution while the counter gear turns only 0.8 revolution. Reverse. In reverse, all the synchronizer sleeves are in neutral. The reverse idler gear slides into mesh with reverse gear on the output shaft. The counter gear drives the reverse idler gear and it drives the output shaft through the synchronizer sleeve. The output shaft turns in the reverse direction because of the reverse idler gear. A typical reverse gear ratio is about 3.5:1.